Lesson 4.2, Introducing Permutation and Factorial Notation. This makes me really excited because factorial notation is the most excited notation of them all. There actually has exclamation marks in it, so I'm pretty excited about that, understandably. Before doing that though, let's define exactly what a permutation is. Now we're going to have two different kinds of questions in, well, lots of different kinds of questions, but two main ideas, permutations and combinations. Now let's just focus on permutations today. So a permutation is an arrangement of distinct and different objects in a specific order. So, for example, objects A and B have two permutations. AB and BA. In a permutation, order matters. Now this might not make a lot of sense because we have nothing to compare it to, but in a combination, just a little sneak preview, in a combination order does not matter. Let's move on to factorial notation. Woohoo! A concise representation of the product. So that means multiplication of consecutive descending natural numbers. So there's actually a lot of stuff that is in there. So consecutive means right beside each other. Okay, so it would be like 6, 5, 4, 3, 2, 1. Consecutive means a difference of 1. And because it says descending, it will never be, 7 times 5 times, 7 times 8 times 9 times 10. It's always going back down to 0. Natural numbers is another important key because there is no 0. Because of course if we included 0 in the product, everything would be 0. So if you would say 3 factorial, it would be 3 times 2 times 1 times 0. That's not super helpful. We're going to be looking at them in specifics. So say something like 5 factorial. That is 5 times 4 times 3 times 2 times 1. Or we're actually also going to be talking about it in general. So n. Now n can represent any number. It can represent 5, it can represent 20, it can represent 1,000,000. But the way that we would say this is we would say, for 5 in specific, let's just go back, we would say 5, then the next number down, so 5 minus 1 is 4. 4 minus 1, or 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 4 is 1. So when we talk about these things in general, we're going to say that n factorial is n times n minus 1 times n minus 2 times n minus 3 all the way. So we're going to say dot dot dot. The ellipsis saying that we just follow the same pattern all the way down until we get something like 3 times 2 times 1. This is a really important thing to understand here. Okay, this factorial notation is going to help us when we find how many ways certain objects can be lined up. Speaking of which, let's go to the first question now. Determine the number of arrangements that 6 children can form while lining up to drink. So we're going to use our information from yesterday, the fundamental counting theorem, saying that when we have distinguishable objects, so say we have 2 distinguishable objects, so like yesterday was shorts and sweaters. In the first example, we said that there were 3 shorts options and 3 sweaters options, so altogether there are 9 outfit options, 3 times 3. So when we're talking about kids, so 1, 2, 3, 4, 5, 6, like yesterday with the digits and the non-repeating digits, when it comes to kids, all kids are different. And so these individual children cannot just say, okay, so you have 6 options available for the head of the line and then 6 more options, because that first kid has now taken a drink. So actually, after the first kid goes, there are 5 options of children to stand in line for the fountain, then 4, then 3, then 2, then 1. This is just using the fundamental counting theorem that we had from yesterday. However, we can see a connection between yesterday's work and today. This, 6 times 5 times 4 times 3 times 2 times 1, that can just be represented as 6 factorial. Now it says determine the number of arrangements. It doesn't say that we can leave it in factorial form. So actually what we need to do is we need to simplify it. 6 times 5 times 4 times 3 times 2 times 1 is 720. So there are 720 different arrangements that 6 kids can stand in a line to wait for a drink at the water fountain.